Hello, everyone. Good morning, good evening, depending on where you are. I am from India, and here it's roughly around 7:30 in the evening. So thank you so much for joining in. It's such a pleasure to talk at Python Web Conference. It's such a wonderful place to be in. So I work for AWS with the Developer Advocates team, and I'm based out of Bangalore, India. And today we are going to discuss about how we can deploy machine learning models on AWS. So there are various ways that we can deploy our machine learning models, but we will see just one of the simple way that we can deploy our machine learning model. So what we are going to discuss in next 30 minutes or so is we will take some small toy example and we will train a model with that data set. So that data set is available, from the Kaggle website. It's a very simple data set. We will look into that, and we will be using a gradient boosting algorithm to train that model. And then what we are going to do is we are going to save that model artifacts, and we will try to make a web application with that model intelligence. Okay, and to make that web application, we will be using Flask. Okay. And how we are going to host that in AWS, we will see, as we go on. Okay, so but this is the whole idea of, of how we are going to spend next 30 minutes. So this is the ultimate thing that we are going to see after 30 minutes if, if the demo works fine. And this is a simple machine learning model which we will be, training for wine prediction. So basically, this data set contains a lot of details about different types of wines that we have, like red wine, white wine, and then different types, different categories or features of that particular wine. So it basically contains what is the pH value, what is the density, how much alcohol it contains, etc. So based on these features, we need to come up with a prediction that whether that wine is very good in quality, or it is medium in quality, or it's it's very lower in grade. Okay, so we will see how we can train that. Okay, so this is the whole idea about this particular machine learning model, and the way that we are going to host is using Elastic Beanstalk. Okay, so we are going to see what Elastic Beanstalk is and how we can deploy our model. But before that, we'll just spend a couple of minutes on the machine learning side of it. So in machine learning, we have different types of learning, or different types of machine learning rather. And one of them is supervised machine learning, where what we do is we take the data set, and all those data set contains the label. That means each data set will tell you what is the class label, because at the end of the day, machine learning is all about prediction. Right, so given a data, you need to predict that whether, like in this example, the problem that we are seeing here is, given an image, we have to say that this image contains what. So in the left hand side, the image contains a baby. In the right hand side, the image contains a dog, etc. So in supervised learning, if we have to build a model like this, what we would need is we would need a lots of image with their class labels. Right, so we may have millions of image, and each image will have some label, like this image contains a car, or this image contains a car and a person. And after that, after taking all those million images and their class label, we need to train a model such that at later point in time, once the training is over, if we give a new image which is never seen by the model before, if we give a new image, it can predict what that image contains. Okay, this is what supervised learning is. And why we call it supervised? Because we are training the model with the data and its class label. Right, so that's the whole idea of supervised learning. So this is how it works. So we give the data, that is the input, this is the input data. And here we are just considering images, but you can think of, any CSV file or any text file with different features and its class label. Okay. And then we will pick up, one of the machine learning algorithm. We have many algorithms, and we are going to use one of them today. But we can pick different algorithm based on the problem that we are trying to solve. And then once the training is over, we will try to do some prediction. And whenever we talk about prediction, the first thing that comes to our mind is how accurate is your prediction, right? So we need to first check the accuracy of our model by checking its actual label. So if we find that, okay, the actual label of this particular prediction is correct, or it's exactly same as it should be, then we can consider that, okay, this model is correct, or this model is doing fairly good. And there are different matrices available to check a model is doing correct or not. So we have different matrices like accuracy, recall, precision, etc. And obviously, since uh, it's an algorithm, and it may not be that it can predict all correctly, we have to then check the model, and we might have to ask for more input data, or we have to tweak some parameters, etc. So that's what adjusting the model stands for. So as we discussed, that there are different algorithms available for machine learning, and different categories of problems that we have. We are going to discuss today about one of the ensemble machine learning algorithm, and specifically boosting. Okay, so ensemble is nothing but uh, you know it's a collection of small or weak learner models. So generally, all these models, like what you see in the right hand side, like decision tree, or this k nearest neighbor, etc., they are one. In those sections, we just create one model, right? But in ensemble models, ensemble learning, what we do is we take small models of different types, and then we make a big model which is much stronger, when we think about it collectively. Okay, so how this boosting algorithm works is, let's say, so before that, we'll just talk about decision tree a little bit, so that we get a context of boosting, because this is very much important. So let's say you have a data set like this, where you have given a different types of fruit, and it has two features, color and size. Okay, and now if I have to classify or make a model using decision tree, what I can do is I will come up with some decision tree like this, where I will pick one of the feature. So we have two features, color and size. So we might pick color. So how we pick which feature, it has a different technique to pick the right feature. But the idea is we have to pick the feature which can segregate your data, or in a right way, or in a most predicted way. So we can split the data set using the color, and since we have three different types of colors here, red, green, and yellow, then we will segregate this whole data set into three different buckets. Okay, and we know that if it's yellow, it has to be lemon. So we know that this is the end. So this is the actual class. So any fruit which is of yellow color, it would be a lemon. So that's what the model will predict. But green could be a lemon or an apple. So again, we have to take another decision based on the size. So like that, it goes on. So here we just have two features, that is color and size. That's why our depth of this tree is only two. Like this is a root node, and then this is the first level, and this is the second level. But imagine that when you have a real data set, where you will be having hundreds of thousands of features, your tree would be very, very long, right? Very deep. And ideally, in most of the time, a single model like this doesn't work that well. And that's why people have come up with something called ensemble methods, or ensemble learning, and where what it does is it creates small models, and you can think of these models as a small decision trees, and they will solve some of the problem, or they will have their own prediction, but that prediction won't be that strong. But when you collect all of these weak learners prediction and make a strong an aggregation or of all these weak learners, your prediction would be very, very high in terms of performance, or in terms of accuracy, with respect to the accuracy that each and every single model will predict. Okay, so one of these one of these way of ensemble methods is gradient boosting, and what it does is it makes a small prediction, or rather a weak prediction of different models. So let's say this is a first learner, and it can just create a decision boundary like this. Like here, the data set contains only two class, square, block, and triangle. And if you see in this first weak learner, it has predicted this two triangle correctly, but these three triangles are different, right? Because it has considered it as a square, but this is not a square, right? So what the second learner would do in gradient boosting is it will prioritize these misclassified objects. Okay, so that's why it is like it's in a little bigger font if you see in the second weak learner, and then it will give more priority to these misclassified objects so that it can be classified correctly, in the next learner. So if you think about it, this weak learner 1, weak learner 2, weak learner 3, these all are sequential. So this all happens one after another. Okay, and it continues till we get a very good model, or we get a very strong learner where all the classes of all the objects are rightly classified. Okay, so this is what gradient boosting is. So now we will be using this algorithm to work on our wine data set. So let's check the code. So all right, so we'll just quickly go over this, and then we will see that how that model works with our Flask application. So this is the this is a very simple import a few of the basic modules that we would need to train the model. And don't worry about this confusion matrix. There is a small wrapper function which I've written to have some performance characterization at later point in time. So we will see what this confusion matrix is at a later point. But the first thing that we do here is we first download the data set. So we download two different types of wines. One is red wine, another is the white wine, and we save it in a pandas data frame. And then we can just do some data analysis, data exploration. So if you see all these data set contains various features like acidity, then citric acid, etc. And then there is something called quality. So this is the actual feature or the class label. So remember that just a couple of minutes back we were discussing about supervised learning, which contains the data as well as the class. So you can think of all these columns from this fixed acidity till alcohol, right? These are all our features. These are the input data, and this is the quality is something that we need to predict. So later on, once the model gets trained, the user will give all these data features for a particular data set, and we have to predict what is that quality. Okay. Now, since we are dealing with two different data set, what we are going to do is we are going to concatenate two different data set into one single data set. And this is what we are doing. We are just doing a pandas concatenate, and we are just coding we are adding a new column called color, so that we know that which data point coming from which data set. So we are adding a new column called color, and if the color is white, we will be having 0, or if it is red, it is 1. Okay, so now we just see that if there is any data which is missing in this data frame, so we can simply call that info function, and we see that it's there is no null or missing data in this data set. Next, we are just trying to see some of the standard characteristics of this data set, like mean, median, mode, and etc. So there's nothing much to see here, but interestingly, we need to first see what are the different qualities we have. So it's actually having what we are doing here is we are just splitting the data into quality, because this is the class feature. This is what we need to predict, and we see that out of almost 5,000 to 6,000 data points we have, it almost 3000 data points belongs to quality 6. And what these numbers are basically, the quality starts from 0 to 9. Okay, although you don't see here 0, 1, 2 because none of the data points have that. But if you go to that website from where we picked that data set, there they say that this data set contains 10 different categories. So category or quality 9 is the best one, and category 1 or 0 is the worst. So this is the range of the quality of the wine that we have. Okay, so now if you see these first three, like 6, 5, and 7, they are actually having most of the data points, right? So it's not a very balanced data set. So what we are going to do is, if we are going to chop we are going to cap a certain number of data points, because machine learning is not the idea for this talk. What we are going to see is how we can deploy this model into a Flask application and into the AWS cloud. So what we are going to do is we are going to make a cap of only 500 entries. Okay, so we will just check each and every group of quality, every quality, and we will just cap it to 500. Okay, if any data point above 500, we will just discard them. Okay, so we are basically shrinking the data point, okay, or data set rather. So when we do so, we see this. So we still have skewed data point, like quality 7 contains 500, quality 6 contains 500, and so on. But if you see these 3, 9, and 8, this still contains very less number of data points. So for machine learning, this is not a very good idea to train a model with this imbalanced data, because at the time of inference later on, it may not perform that well for these classes. Okay, so what we are going to do is we will club few of the quality. So what we are going to do is we will club 3, 4, 5 into a new quality called 3. Then 6 will remain 6, and 7, 8, 9 we will call it as 9. So basically, you can think of it as this is the low quality, this is the medium quality, this is the high quality. Okay, just to make our life little simple, and we will just have 3 different types of wine quality. Okay, so this is what we are doing, nothing fancy here. We are just playing with some pandas filter methods, and then we are going to save the data set. Okay, so now we have these 3 different categories, and now it's more or less it's little balanced, although we don't have much data point for class 9, but that's okay. All right, so now we have clubbed all these categorized these into 3 different sets. What we are going to do next is we are going to split the data between training and testing. So this is what a general practice for any machine learning training. What we do is if we have 100 data points, we roughly train the model with 80 data points or 70 data points, and 20 to 30% we keep it for testing. So the idea is, once that training is done, we will throw those test data sets and we will try to see what the model predicts. And since this data set also contains the class label, we can compare the predicted value with the actual class label, so that we know what is the accuracy and the precision of our model. So we are using Scikit-learn's train split method, and once we run this with our data set, and we are here saying that, okay, just split 80% for training and 20% for testing. Okay, so now we have 4 different variables. Xtrain contains the training data set, and which is the 80% of the data. Xtest contains the 20% of data, which is the test data set. And Ytrain and Ytest are the class label of Xtrain and Xtest respectively. Okay, so this is what, so we are now ready for start the training. So now we are going to use gradient boosting classifier, which is also available in Scikit-learn. This is not a very good implementation of gradient boosting classifier, but it's fairly okay for us as we are playing around. Okay, so what we are going to do is we are going to call this, and we are saying that we are going to use decision tree, because by default here I'm not mentioning which model to use, because gradient boosting, as we discussed before, it is a ensemble method, so it will have lots of weak learners. So by default it will take a decision tree, and each decision tree will have a maximum of 10 depth. Okay, this you can change it to 3, 4, whatever it is. Okay, so it's up to you. And then this is the main important thing. So let me uncomment this. So once this training is done, okay, once this training is done, we are going to save that model artifact. And how we are going to do this is using pickle. So we are dumping this model into a variable, and then we are going to save that into a file called gbm model dump.p. So this is the file which contains our model, which is a trained model, and this we are going to use in our Flask application. Okay, so once this is done, we can do some prediction, right? So now if you see the prediction, here, if we do the prediction for our data set, we will see that the predicted value comes in something like this. Like it's actually a probability of because we have three classes, right? Class 3, class 6, or class 9. These are the three different category of wine that we have specified. So it returns the probability of how much it belongs to each category. Okay, so we can obviously pick the maximum one, and we can say that, okay, this is the class that it belongs to, or this is the quality of the wine that we have. Okay, so now if you see the precision, it's not that good. It's roughly around 74%, but that's okay. We can live with that. And this confusion matrix will tell us, how good is our model. So if you see our when we pass this data or the predicted value to confusion matrix, it can tell you that if you see, we have three different classes, 3, 6, and 9. And if you see the diagonal elements, this tells you that how much correct your predictions were. Like if an actual class is actually, if the actual label is 3 and you have also predicted 3, then it will come here like 351 amount of data points are rightly classified as class 3. Whereas if you see this 107, where our model predicted it as a 6 category, but the actual class was 3. So this is not good, right? So the best model will be such that you will find the bigger numbers in the diagonal of this matrix. Okay, so this is one of the way that you can actually visualize, how good your training model is. Okay, so that's all that I want to show you. But the important thing that to keep in mind is, we have saved our model, into a file, right? So let's go back to our presentation, and we'll quickly see how we can deploy this. So we have something called Elastic Beanstalk, and what Elastic Beanstalk can do is it can deploy your a web application onto the cloud without managing anything of your own. So basically, when we run a web application on AWS, we generally first provision the configuration, like you need some virtual machine, then you need some load balancer, you need some security group, etc., etc. So there are a lot of things that you need to do of your own, and then you deploy your code, right? So let's say it's a Flask application or .NET or whatever it is, and then you have to manage them. But this takes a lot of time, right? And it is quite cumbersome at times to do all of these, because we have lots of services to pick from at AWS. Like for networking itself, we have a lot of different services. For compute, we have different services. So is there a way that we can automate all of this? And Elastic Beanstalk is one of the solution. It's not the only one, but this is one of the solution, where you can simply write your code. Okay, you can simply write your code, and you can just tell Beanstalk that, okay, this is my Python code, and I need to host this website, and this web application is developed using Flask. That's all you have to tell. And rest everything, whatever we have seen, like how that load balancer will be configured, how and the auto scaling group will be configured. Everything will be taken care by Elastic Beanstalk, and it can scale based on the workload. And how it works? It works very, very seamlessly, and it's very simple. We have to first create an application called this using CLI. In UI, you can do it through the AWS console, but CLI is more preferred, right, for developers. So you have to first install that EB CLI or Elastic Beanstalk CLI. And the first thing that you need to do is EB init, and then you have to do EB create and EB deploy. So what EB init does it? So let me do this, then it would make more sense. So what we are going to do is let's see, where are we? Yeah, so here first we have to create a virtual environment. If you want, it's always a best practice. So we can create that. I guess I'm already there. Okay, so next thing is you have to activate that, and I'll just install the required packages for my application, which is a standard thing. And then I'll show you the application. So first, we will run it in our local system. So this application.py is actually, let me show you the code. This application.py is actually taking the same model that we have created, okay, during the training time, and that's all. And then what we are trying to do is we are going to read all these features. Now what we have, all these features means if you remember, if I can show you this, all these features, right? Fixed acidity, volatile acidity, and etc. So we are going to read this from the user, and then we can predict the quality, all right? So we are just creating a hash which can contain all of these data set, which the user provides. And then we will call this, a predict function. And whatever we get, we will just, tell the user that it is of what category, okay? So now let's go back to our code, and we are running this in our local laptop, right? In my laptop. So let's open this and see that how it looks like. So if you see, this is now running in my local laptop, right? And if you check different if you change this slider, which is actually, pushing a new JSON in the backend, and that gets that interference going to that model, and the model is returning that it's of low quality, and you can change it, and you can check. Now it is saying it's a high quality. If you can see, let me zoom in out a little bit. Yeah, so this is how that model is predicting. And this is hosted on my local laptop, and it's using Flask. It's a very simple app. If you want to play around, you can do that. I'll share the GitHub link, but it's a fairly simple app. And you might have noticed that I have a weird way of declaring this. The reason is Elastic Beanstalk. I'm using the latest 3.7 version, and the application name should be app. Okay, so it's not application, which was there in the previous version. So it was failing for some reason. Then I figured out this was the reason. So that's why I did not change this variable everywhere, but I just changed it in the one line in the initial stage, and then I just changed here at the very bottom. Okay, the simple Flask app. Okay, so now I'm just closing this. Okay, and I don't want to run it in my laptop. The idea is I need to host it in, into AWS cloud. So the way we can do this is EB init, right? As we have seen in the presentation. But I'm giving some optional, parameters. If you don't give this, that is also fine. But in that case, it will keep you asking some questions, so that you need to know, you need to tell Elastic Beanstalk that what type of code you are going to run and in which region you need to host this, right? So at this point, we have just created an application. Okay, so now if you go to AWS console and come to Elastic Beanstalk and come to application, you will see that the application is now there, which we just created. Okay, but if you come inside, okay, so I guess it's okay, so I guess it's an old one, which just 1 second. Okay, so let's do this. So let me first create that environment. Okay, so what is happening is that it will take 5 minutes or so, but I have taken a screenshot where I can show you this. Okay, so the first thing when you do this, it just creates it application, but it doesn't create the environment. Okay, but now when you say eb create Flask and any name, actually we have given a name of Flask environment wine demo. What it will create is it will create everything of its own automatically. It will create a EC2 machine for you, which is a virtual instance in AWS. It will create a auto scaling group which can scale your application across across your EC2 machines. So suppose your workload is very less today. So in that case, it might use just one EC2 instance. Your workload might go up tomorrow. So it will automatically scale, based on your configuration that you provide into auto scaling group. And it will also, create, configure your CloudWatch alarm. So CloudWatch is for logging purpose. So you can debug your application, what it is doing, how it is doing, etc. So all of these, Elastic Beanstalk takes care for you. So you don't have to worry about any of these things. Okay, so let's see how far we are there. So it's still creating. Okay, so let's give it a couple of minutes. So it should be over. So in the meantime, we can see what is happening in our console. So the fact that you see two is because I actually created one before this demo, and I did not deleted that mostly, and that's why it created two environments. That is one of the reasons for that. But if you go to EC2, let's say we go to EC2 and try to come here and see. If you see here, now we have a new instance, and this is what we have named. If you see here, this is the name that we have given, right? So the same thing is actually came up here. So this is the instance which got created by Elastic Beanstalk, right? And it is still in an initialization stage. And once this is done, we should be able to open our application. Okay, so let's wait for this to complete. And in case, after the session, if you have any questions or queries regarding Elastic Beanstalk, because I know that we just rushed through that, feel free to ask. Would be happy to help you, because Elastic Beanstalk can do a lot of things. I'll try to show you a few of the infrastructure that it has created behind this screen, which you see here. Like it has created a security group, auto scaling group, load balancer. These all are very much needed for any web application, right? So we will look into that if time permits. Otherwise, you can play around this into your AWS account, and you can feel free to reach out to me if you have any questions. Okay, so let's wait for a couple of minutes. Okay, so here it is. Let's see. Okay, so if you see now, although we'll just wait for, okay. Now here in the command line, you see that it's got completed, right? It created the environment for us. And now if you just run EB open, it will show up in your browser. And this is now the same application, but we are now hosted on AWS. right? And if you see change here, and you can see the same prediction. Now, the thing that it did in the backend is when you ran this command, create this environment, right? What it did was, in this present working directory, it zipped everything, okay, and it has put it into S3 bucket, and there only we pushed everything, like we pushed the code, that is your app.py. This is the application, Flask application, and we also had that model, right? So the model is inside pickle, right? This is the model that we developed using the Jupyter notebook, right? So everything in this present working directory, it's zipped and it is saved into S3 bucket. And if you see it here in the environment, if you see it here and come to left hand side, called configuration, you would see that what are the things that it has done. So it has created some instance, which is a EC2 instance, and it also created a load balancer for you. And if you want, you can edit it. Then it also tells you what is the rolling update or deployment strategy. So we have not mentioned this. If you remember, in the command line, we have just said this create Flask demo app, and during the initialization also we did not mention anything. So it used a policy type of all at once. So what that means is, let's say I want to change the I have changed the application now, and I need to deploy a new version. So what we have to do is, I need to change the code. So let's say in place of high, I just say very high. Okay, I will just say this and save this file. Okay, I just saved this. And now what I can do is I can just say EB deploy. Okay, so when I do so, what happens is it again take those changed file, and it will create a new zip file, and it will throw it back to AWS cloud. But when we have this option all at once, what that means is, if your application is running into 3 or 5 EC2 instances, it will make the changes in all the instances at a time, at the same time. So there might be a fraction of a second of downtime when it will change from version 1 to version 2. Right, so there will be some breakage time where the application may not be available. So it might be a very fraction of seconds or so. But there are different strategies available, like we have rolling update, and there are different types of updates where we update a few of your EC2 machines with the new version, and few are still there in the old version. So during that time, your application will never go down, but it might so happen, if I open your web app, I might get an older version, and somebody else who is opening from some other place, he might get a new version. But everybody will get a latest version, but after a certain point in time. So that is what is rolling update is. So if you want to change this, you can always come to edit and change the policy. So we have different policies, and we can change that. So this is something that you can do through UI as well as through CLI. But I just want to show you the capability of Elastic Beanstalk, what it has done under the hood. So it also created a load balancer for you, and security group, etc., etc. And you can also check the log. So if you just come to log, and you can request last 100 lines of log. So the nice thing is, you are still not logged into your EC2 machine, right? All you are doing is through your console. And I have just downloaded the last 100 lines of logs from that machine. So this is the Elastic Beanstalk engine log, but similarly, you can get all the logs, like here, std out log, this is from the web socket, this is from the Nginx. So the idea is, this is a single frame where you can get all the information, and you don't have to, toggle through your application and the infrastructure that you have. All you have to do is you have to focus on your code, right? And you don't have to worry about the environment at all. Now, if you see, let me go back to the application again, and let's see where we are. Okay, it has successfully updated. So let's do EB open. So I'm using command line, but similarly, you can do it through your UI as well. So now let's try to change. See this, now we have changed this 9 to very high, right? If you remember in the code, this is the change that we did, right? It was high before, but now we have changed it to very high. So that a change we could deploy in a fraction of a second, right? So in just a minute. So this is the beauty of Elastic Beanstalk. So you can just focus on your code. You don't have to worry about scale and how we can manage the infrastructure where our application is running. Everything will be seamlessly done by AWS at the back end. So that's all that I have, for this talk. And lastly, I just want to show you how you can destroy the whole environment. Okay, so the way that you can do this is simply saying EB terminate. So what this will do is it will destroy your whole environment. So it will destroy your EC2 instances that it got created. It will destroy the load balancer, auto scaling group, everything. So you don't have to write any script to destroy all of these infrastructure that it got created because of this. And once this is done, you can simply delete that application as well. So that's how you can play around with your application with Elastic Beanstalk. Okay, so once this command gets over, after some time we will see that here we will not have that environment at all. Okay, so it's still going on. So it will take a couple of minutes to destroy the whole infrastructure. All right, so that's all I have for today. And I just thought, this is generally that we do in India in most of the events, that wherever we go and talk, you may like to scan this. You may get some credit, and in case you will get a credit code which you can use in your AWS account. I think $20 to $25, something like that. And in case that code doesn't work, because at times I heard from a lot of people that code didn't work, feel free to ping me on LinkedIn or Twitter. I will try to just message me directly. I will try to send you a correct code. Okay, so this is rating.go-aws.com/rate/142. Okay, so if you missed it, you can ping me on Slack, and then I will share the link again. So thank you so much for your time. It was such a wonderful opportunity to interact with all of you. I'll be there on Slack. Feel free to ask questions, and I can share my GitHub repo as well. You can simply go and make changes or play around with that. Okay. So with that, I will turn it back to Mary. Thank you so much for your time.